In exactly 5 days, on January 22nd at precisely 1 p.m. GMT, something extraordinary will happen in our solar system. For the first time in recorded history, Earth will pass almost directly between the Sun and an interstellar visitor, a wanderer from another star system that has traveled through the cosmic void for 7 billion years. Harvard professor Avi Loeb calls it an unprecedented near-opposition alignment. NASA has every major telescope pointed at the sky, and the question everyone's asking is, what will we see when Earth, Sun, and this mysterious traveler align with mathematical precision? Welcome back. The object is called 3I Atlas, the third confirmed interstellar visitor ever detected. But this isn't just another astronomical curiosity passing through our neighborhood. On January 22nd, the phase angle between the Sun 3I Atlas axis and the Sun-Earth axis will reach an incredibly rare 0.69 degrees. In simpler terms, we'll be looking almost directly back at the Sun's light reflecting off this ancient object. For approximately 1 week, between January 19th and 26th, we'll have a viewing window that astronomers have been preparing for since July. Why does this matter? Because of what happened just last week. On January 6th, NASA held a press conference that should have settled the debate. After months of observations from the Green Bank telescope, the most sensitive radio observatory in the world, searching for any signal, any hint of artificial transmission, the conclusion was clear. We all would have been thrilled to find technosignatures coming from 3I Atlas, said lead researcher Benjamin Jacobson Bell from UC Berkeley, but they're just not there. The search found no radio signals stronger than a modern cell phone. According to NASA, 3I Atlas is a comet, natural, ancient, perfectly ordinary cosmic ice and rock. But here's where it gets interesting. Professor Avi Loeb, the Harvard astrophysicist who directs the Galileo project searching for evidence of extraterrestrial technology, isn't ready to close the book. Just 3 days ago, Loeb published a new research paper focusing specifically on this upcoming alignment. He argues that the unique opposition geometry provides what he calls a narrow but well-defined observational window to answer fundamental questions NASA hasn't fully addressed. Think about what we're really looking at here. This object is 4 to 5 kilometers across, significantly larger than the previous interstellar visitors Oumuamua and Borisov. Current estimates suggest it formed over 7 billion years ago, meaning it's older than our entire solar system. Here's what makes January 22nd so critical. When Earth positions itself nearly between the Sun and 3I Atlas, we'll observe what astronomers call an opposition surge, a dramatic brightening effect when sunlight reflects directly back toward us. This isn't just about seeing the object more clearly. The way light scatters from the dust and ice particles will reveal information we simply cannot get any other way. Loeb's paper asks specific questions. Is the dust dominated by carbonaceous material with low reflectivity, or does it contain significant ice fragments? Are the grains compact, suggesting thermal processing in its home system, or fluffy fractal aggregates indicating pristine molecular cloud material unchanged for billions of years? The opposition surge will answer these questions, and those answers will tell us about conditions in another star system, light years away, billions of years ago. NASA says it's a comet. The data shows gas, dust, a developing tail, all the classic signatures. The James Webb Space Telescope detected carbon dioxide, carbon monoxide, water, ice, everything you'd expect. But Loeb argues we need to be certain. After all, Oumuamua in 2017 looked nothing like a traditional comet. It showed no tail, no coma, yet exhibited non-gravitational acceleration that scientists still debate. What do you think? Is NASA right to close this chapter and move on? Or does Loeb have a point that we should use every possible observation window before this visitor disappears forever? Write your thoughts in the comments. The timing makes this even more remarkable. Right now, 3I Atlas is 3.33 astronomical units from the Sun. It's 2.35 astronomical units from Earth, roughly 220 million miles away. At opposition, we'll see details impossible to observe when viewing the object from an angle. Unlike typical cometary opposition events that last only hours, 3I Atlas will maintain this favorable alignment for nearly a week. This is likely our last chance. After January 22nd, 3I Atlas continues its journey outward. In March 2026, it will pass Jupiter at a distance of 33 million miles. Then it heads toward the constellation border between Gemini and Orion, accelerating back to interstellar speeds. In approximately 8,000 years, it will pierce through the Oort cloud and leave our solar system permanently, traveling at 58 kilometers per second into the cosmic void. For those of us who remember the Apollo era, who watched humanity reach for the moon, there's something profound about this moment. We're not just observers anymore. We have the technology to track visitors from other stars, to analyze their composition, to ask questions our parents and grandparents couldn't even imagine. So mark your calendar. January 22nd. While you can't see 3i Atlas with the naked eye, professional and amateur astronomers worldwide will be watching, documenting this unprecedented alignment. And in the data they collect, we might finally understand where this ancient wanderer truly came from. What would you ask if you could send a message to the civilization that might exist around the star where 3i Atlas was born 7 billion years ago? Share your thoughts below, and until next time, keep looking up.